Okay, this is the review for the circles unit, circle units review. So number one here, we're just simply naming radius, chords, diameters, central angles, inscribed angles, minor arcs, major arcs, and semicircles. So let's start with radius. Okay, so a radius is, we can think of it as the distance between the center point and any point on the circle, or we can think of it as the segment that connects the center of the circle to any point on the circle. So if we think about it as a segment, we can see what's drawn in here. So we need a point in the center. So O is the center of our circle. So this would be circle O. And so a radius is going to connect the center of that circle to any point on the circle. So O to P would be a radius. It connects the center to the point on the circle. OM would work. Okay, O is the center, M is a point on the circle. So right here we have a radius. Okay, and then O to N would also be a radius. Okay, O to N. Okay. So a radius connects, links the center of the circle to the distance from the center of the circle to a point on the circle, or we can think of it as the segment connecting the center of the circle to a point on the circle. Remember that the center of the circle is not part of the circle. The circle is the infinite amount of points that are the same distance away from a central point. Okay. Chords. So chords are segments that connect 2 points on the circle. So we want to pick 2 points that are on the circle. For example, M and Q are both on the circle, and we have a segment linking them together, joining them together. So we're going to have MQ. Okay. QN. Okay, 2 points on a circle, and they're linked together by a segment. So that's QN. The third one on here is MN. So M and N are both on the circle, and we have a segment linking them together. So segment MN is a chord. The other segment on here is PO, but PO is not a chord because it doesn't connect 2 points that are on the circle. P is on the circle, but O is not on the circle, so PO is not a chord. Chord links 2 points that are on the circle. Diameter is a chord that goes through the center. Okay, it's basically it goes across the circle, so across half, splits it in half basically, goes across the circle, but formally it's a chord that goes through the center. So MN was one of our chords. So MN is our diameter. Again, we can name it NM if we want it instead of MN. Same thing. We have 2 types of angles, central angles and inscribed angles. Central angles, the vertex of a central angle is the center. The vertex of an inscribed angle is on the circle. So our central angles here, we have POM, angle, POM. Okay, the vertex, here's our central angle. Okay, so the vertex is O. O is on the circle, so it's a central angle. O is the center of the circle, so it is a central angle. We also have PON. Angle PON is a central angle because the vertex is O, and O is the center of the circle. So angle PON. Then lastly, a third one, we have angle MON, which is a straight angle. So we have a straight angle that's 180 degrees. It's a straight angle, but still a central angle. Name 3 inscribed angles. So central angles were angles where the vertex was the center. Inscribed angles are angles where the vertex is on the circle. So if we look for other angles in our circle, we notice we have one down here. Okay. To determine whether or not it's inscribed, we need to look at the vertex. The vertex of this angle, where the 2 rays that make up the angle meet, is Q. Is Q on the circle? Yes, Q is on the circle. So angle Q is an inscribed angle. We could also name it angle MQN. This is angle MQN. The vertex is Q. Therefore, it's an inscribed angle because the vertex is on the circle. Other inscribed angles here, we would have Q and M. So here's angle Q and M. Inscribed angle because the vertex N is on the circle. And the last one we have here is angle NMQ. And angle NMQ is an inscribed angle because angle M is the vertex and it's on the circle. Okay, minor arcs, major arcs, and semicircles. So an arc is part of the circle. So again, the circle is the infinite amount of points that go that are all equidistant from the center of the circle. So it's the line, it's all these points together, the set of points around the circle. Around the center that are all the same distance from the center. We have we want to name 3 minor arcs, 3 major arcs, and 2 semicircles. So arcs are part of that circle. They're part of the circle. They're not the whole thing. If that part of the circle is more than half, it's a major arc. If it's less than half, it's a minor arc. If it's exactly half, then it's a semicircle. So a minor arc, for example, would be MP. It's less than half of the circle. We name it using the 2 points we're connecting. We're connecting M to P. And then we put the arc symbol going from M to P. Another minor arc we could have would be PN. So P to N is a minor arc. It's a part of the circle, but it's less than half. We could also do MQ. MQ. Other ones would be QM and PQ. So there's 5 minor arcs on here. Major arcs are arcs that are more than half the circle, so they're greater than 180 degrees. So we can go, for example, from P through M and Q over to N. Okay, to name that, we want to use 3 points. So we're connecting points P and N. We want to also name one of the points we're going through. So again, if you just write PN, it's assumed you're going the shortest way along the circle. There's 2 ways to connect P and N. The short way and the long way. If you go the short way, you're just calling it arc PN with 2 points. If you're going the long way, you got to pick one of the other points to tell us that's the way you're going. So we could either use M or Q. Let's just use M. So P, M, N, and again, our arc's linking P to N. We're going through M. We could have easily said PQ, N as well. Okay, another major arc. How about M? How about M, N, P? Again, more than half, so M, N, P would work. We could also do QNP, would be a major arc. It's more than half. Q, N, P. Semicircles are half, so if we notice, we have 2 ways to connect. We have a diameter here. MN is our diameter. We have 2 ways to connect M and N. We can go up top or we can go below. So if we went up, that would be arc MPN. And again, if you just write MN, we don't know if you went up or down. So you have to have that 3rd point to specify which way you went. So that blue arc there, that top semicircle is going to be MPN. All right, we're connecting M to N and we're going through point P. And then the lower the lower half here, m through q over to n, that's going to be m q n. So this top one, we went through point P, halfway around. Here we went from end to end, halfway around, but we went through point Q. So that's number one. Number two, find the radius, diameter, area, and circumference of the following circles. So radius is 7. Okay, radius is the distance here from the center to the circle, so that's 7. Diameter is twice the radius. So all we do is 2 times 7, and that's going to be 14. Okay, we want to find the area and circumference. So area is pi r squared. All we do is substitute in the radius, so that's pi times 7 squared, and that's going to give us 49 pi. Okay. Let me do it down here, actually, I don't like. Okay, and then we have circumference equals 2 pi r. Okay, the radius again is 7, so that's going to be 2 times pi times 7, so that's going to be 14 pi. Okay, circumference, area, diameter, radius. We just are given the radius of 7. We double it to get 14. Plug it into the area equation to get 49 pi. Plug it into the circumference equation to get 14 pi. Okay, you can leave it in terms of pi, or you can multiply it out and get a decimal. Both are perfectly acceptable. Okay, the second one here, they are giving us a diameter. So the diameter is 18. So to find the radius, we have to divide by 2. So our radius is going to be 9. Radius is half the diameter, where the diameter is double the radius. We got to find area and circumference. So again, area is pi r squared, right, which is going to be pi times 9 squared, which is 81 pi. And circumference equals 2 pi r. And again, the radius is 9, so we get circumference equals 18 pi. Area is 81 pi, diameter is 9. Diameter is 18, radius is 9. Okay. Find the area of a circle with a circumference of 22 pi. So we want to find the area of a circle. So area equals pi r squared. So in order to find the area, we need to find the radius. So we're going to have to use the circumference to find the radius. So the formula for circumference is 2 pi r. Okay, so the circumference is 22 pi, so we can substitute that in for c. So we get 22 pi equals 2 pi r. Want to get r, we're solving for r, so we can use it in the area equation. So we need to get r by itself, so we need to divide by 2 pi on both sides. Okay, and that's going to leave us with 11 equals r. We can then substitute 11 in for r, so we get a equals pi times 11 squared, which is going to be 121 pi. Okay, so that's our area. So we use the circumference to find the radius, and we take the radius, substitute it into the area equation, and we get 121 pi. Number 4 is just the opposite. We want to find the circumference. So we want to find c equals 2 pi r. In order to find the circumference, we need a radius. So we have to use the area to find the radius. So area is pi r squared. So the area is 36. So 36 pi, or it's 36 pi. So 36 pi equals pi r squared. If we divide both sides by pi, we get 36 equals r squared. Square root both sides. We get plus or minus 6 equals r, but we can't have a negative radius, so it's just going to be positive 6. We can then substitute positive 6 in for r. So circumference equals 2 pi times 6, which is 12 pi, or 38 point something. So again, we just start with what they have. And so they're giving us area. We use the area to find the radius. Then we take the radius and substitute in for r to find the circumference. Okay, number 5, we want to find the measure of the missing angle or arc. Okay, so there, first one, we have to figure out, well, first thing we have to figure out is, do we have a central angle or an inscribed angle? For the first one, we have a central angle because the vertex of the angle, here's our angle, 140. So here's the angle. It's our angle. The vertex of that angle is E. E is in the center of the circle, so it's a central angle. So we know this one, we have a central angle. The measure of a central angle is going to equal the measure of the intercepted arc. So the measure of WF here is going to be 140. Measure of the central angle equals the measure of the intercepted arc. Second one, again, we have a central angle. O is the vertex of the angle, angle AOB. Since O is the vertex, the measure of angle AOB is going to be equal to the measure of arc AB, the intercepted arc. So X is going to be 82. For the next one, we have an inscribed angle. Okay, so here's our angle BAC. Our intercepted arc is BC. So we know if we're looking for this angle, it's an inscribed angle. So it's going to be half the intercepted arc. So 80 divided by 2 is 40. Okay, the last one, again, we have an inscribed arc. Okay. Oops. Oops. I could draw on the line. Okay. So our intercepted arc here is WB. Okay, so the measure of the intercepted arc is going to be twice the measure of the inscribed angle. So this is going to be 42 times 2, which is 84. Okay, so again, the central measure of the central angle equals the measure of the arc. Measure of the central angle equals the measure of the arc. Here we have an inscribed angle, so we have to double it to get the angle. I mean the arc. We double the measure of the inscribed angle to get the measure of the intercepted arc. Here we are given the angle, we double it to get 84. We give them the arc, we divide by 2 to get 40. So the inscribed angle is half of the arc is double the angle. 6, 7, and 8. So we want to find the measure of the indicated arc or angle. So we want to find the measure of TR, which is going to be this arc, measure of arc TR. Okay, so the first thing we want to do is we want to look for semicircles or full circles. Here we have a semicircle. You know the measure of a semicircle is 180 degrees. So we know that red arc right there is 180. So 180 minus 133 is going to give us 47. Right? 47 plus 133 is 108. Okay? So we did 180 minus 133 and got 47. We want the measure of arc TR. So that's going to be 47 plus 61, which is 108. 108. Let me switch back to blue. It's a little darker. Number 7 here. So here we have an inscribed angle. So the inscribed angle is half the measure of the arc. So if we have 49 degrees, we want to find the measure of arc BC. That's going to be double, so that's going to be 98. Okay, the measure of the intercepted arc is twice the measure of the inscribed angle. Here again we have a inscribed angle. The vertex C is on the circle, so we have an inscribed angle. Our intercepted arc is BD, or DB, which is double the measure of the inscribed angle, so this is going to be 140. Okay. which means we can then measure the whole thing, which is 360, minus 140, minus 98, which is going to give us, I'm sorry, yeah, minus 98, not 90. That's going to be 220, 122. Okay. The other way we can do it is we have three angles of a triangle. So we know the three angles of a triangle add up to 180. So 180 minus 70 minus 49 is going to give us 61. So we know this angle here is 61. And then here we have, that angle is an inscribed angle. So our intercepted arc is 61 times 2, which is 122. So either way, we get 122. Third one here. So again, it's an inscribed angle. Angle QSR is an inscribed angle. So here's our inscribed angle. So the measure of arc QR is twice the measure of the inscribed angle. So 95 times 2 is 190. Okay. And then we know the whole thing is 360. Okay. So 360 minus 190 minus 75 is going to give us SQ. So that's 170, 95. So here we have 90. Okay, 9, 10, and 11. 9, 10, and 11. Okay. So this is a central angle. So if the measure of this angle is negative 16x minus 4, the measure of this one is going to be negative 16x minus 4, measure of this arc. Okay. Then we notice we have a semicircle here. So the measure of a semicircle is 180 degrees. So we have negative 16x minus 4 plus 40 is going to equal 180. Combined like terms, we have negative 16x plus 36 equals 180. Okay, we can subtract 36 from both sides. And we get negative 16x equals 144. Then we can divide by negative 16, and we get x equals a negative, let's see, probably 9. I'm going to guess 9. Did you guess? Okay, negative 9. And all we want is x. And we can plug it in, substitute it back in to see if it makes sense. So negative 16 times negative 9. Right, so this piece should be 140 because 180 minus 40 is 140. So negative 16 times negative 9 minus 4 should be 140, and it is. So we know we're right. Okay, number 10. This is an inscribed angle right here. We know the measure of the intercepted arc from an inscribed angle is going to be double. So the measure of the arc is going to be twice. So 2 times 6x plus 11, which is, if we distribute, 12x plus 22. All right, so the measure of arc WT is twice 6x plus 11, so 12x plus 22. And then we know all three arcs here will add up to 360. So 12x plus 22 plus 8x minus 8 plus 126 equals 360. Combine like terms, here we get 20x. That's going to be 22 minus 8 is 14. That's 140. So plus 140 equals 360. We can subtract 140 from both sides. We get 20x equals, what is that, 220 divided by 20, and we get x equals 11. Okay, we can substitute that back in to just make sure we're right. So 6 times 11, 66, that's 77. So this should be 144. So 144 plus 126 plus, what is that, 88, 80. So that's 260. Oh no, wait, 77 times 2 is going to be 154, right? $154. So 154 plus 126 plus 80 is 360. Yes. So that's all equal to 360, so we know we're right. X equals 11. Okay, number 11. Number 11 here, we have an inscribed angle. So again, the measure of the arc is going to be double. Okay. We also know this arc is a semicircle. So we know the measure of it's going to be 180. Okay, so this is, again, 2 times 8x plus 10. It's double what the inscribed angle is, so that's 16x plus 20. And again, we know this is a semicircle, so we also know it's 180. So 16x plus 20 is going to equal 180. Subtract 20 from both sides. 16x equals 160. Divide by 16. We get x equals 10. We can substitute it back into C. So 8 times 10 is 80. 80 plus 10 is 90. Double it to get the arc. That's 180. So another good answer there. 12, 13, and 14. So this one we want to, now we're not just solving for these we just solved for x. The last 3 here, we're not just solving for x, we are looking for what they're asking, the measure of LGH, the measure of WX, the measure of angle TPU. All right, so let me scroll up a little more. Okay. First thing I notice on number 12 is a semicircle, because I'm looking for semicircles. A lot of these problems have semicircles, so I continue to look for them, so I can solve them. Okay, so the measure of a semicircle is 180 degrees. So again, we have x plus 124 equal or plus x plus 62 equals 180. So x plus 124 plus x plus 62 equals 180. That's going to be 2x. Combine like terms, we have 2x. This is going to be plus 186 equals 180. Subtract 186 from both sides. We get 2x equals negative 6. And we can divide both sides by 2. And we get x equals negative 3. We're not done because we want to find the measure of angle LGH. So LGH is right here. Okay. So since we know LGH is a central angle, it's a central angle because J is the center of the circle. We know that the measure of the intercepted arc is going to equal the measure of the central angle. So this is going to be x plus 124 as well. So all we have to do to find the measure of LGH is substitute in negative 3 for x. So we have x plus 124. Substitute in negative 3 plus 124 is going to be 121. So the measure of angle LGH is 121. So that's the measure angle LGH equals 121. Number 13, we have angle XVW is an inscribed angle. Okay. So this one was a central angle, and we know the measure of the central angle is equal to the measure of the intercepted arc. Here we have an inscribed angle because V is the vertex, and that is on the circle. So it's an inscribed angle, and we know the measure of an inscribed angle is half the measure of the intercepted arc. So this number is twice as large as that one. So we need to multiply, here's the arc, And we need to multiply the angle by 2. So we have 2 times 6x plus 11 equals 14x plus 4. So this is the measure of the inscribed angle, and the measure of the intercepted arc is double what the angle is. So if we want to make these equal, we have to double 6x plus 11. If we double 6x plus 11, it's going to be 12x plus 22. Right? You got to make sure you distribute. 6x plus 11 doubled is 12x plus 22. Distribute the 2. Okay, then that equals 14x plus 4. Okay, subtract 12x from both sides. And we get 22 equals 2x plus 4. Subtract 4 from both sides. We get 18 equals 2x. Divide by 2. And we get x equals 9. We're not looking just for x, though. We're looking for the measure of wx, which is this arc right here. So that's going to be 14 times 9 plus 4. So 14 times 10 is 140. So 140 minus 14 is 126. And then 126 plus 4 is 130. So the measure of arc wx is 130. Number 14. Well, we'll do 2 parts. So I'll do number 14, and then we will stop the video and then do a part 2. So number 14 here, if we notice, we have vertical angles. So all we're doing with these vertical angles is setting them equal to each other. Okay, so L11x minus 5 is going to equal 9x plus 5. Subtract 9x. We get 2x minus 5 equals 5. Add 5. We get 2x equals 10. Divide by 2. And we get x equals 5. We want the measure. So just to check and make sure the x is right, 5 times 9 is 45. 45 plus 5 is 50. 5 times 11 is 55. 55 minus 5 is 50. So we know x is right. We want to find the measure of angle TPU. So all we do is substitute that in. So 9x plus 5. So 9 times 5 plus 5. 45 plus 5 is 50. So the measure of angle TPU is 50. And so that's the first page of the review. I'm going to just do 2 parts, 2 different videos, just in case I screw something up. So that's part 1. So definitely go watch part 2 if you need it. If you don't, then definitely don't.